And yes, we started recording. So the first thing I'm going to do is go to our class notebook. And I want to just show you, here's our agenda. Again, we already talked about tomorrow being the last day of the first quarter. So if you have any questions about 2.6 or the notes, here's the first day to do that. There's two more types of proofs in 2.6. It's touched on briefly, and it's summarized in one page. And so that summary of the three types in the class notebook, I put right here. So it's under your class notebook. I did not put it in your individual notebook. It's under the content library. And so this is what the PowerPoint is about that I'm going to be showing you. So here's the three types of proofs. I'm going to click open here. And what we've been doing, this is page 110, by the way, is called two-column proofs. Statements and reasons, left and right. We're going to continue to do this for the bulk of our work. However, there's another type called a flowchart. And especially if you're like really good at programming or something like that, or it's just a different way of thinking, maybe you like it graphically. What you do is you put your reasoning, like your statements, in boxes, or as you can see, like little circle things. And you put the reasons underneath it. So this is your statement, this is your reason. And then to get to the next step, instead of numbering it like 1, 2, 3, 4, you press an arrow to the next one, an arrow to the next one. And so flowcharts can be, it's the same information, it's the same type of proof. It just looks different. And some people like it better. For the most part, like I said, I'll show you one or two in the PowerPoint, and I'll show you side-by-side comparison, but that's about as much as we're going to do right now with it. Paragraph proof, we're actually going to revisit in chapter 6, but for right now, basically a paragraph proof is where you just write everything out in sentences. That's all you do. You write it out in sentences, and you say this because of this because of that, this because of this, and this because of that. So it's simply the same information written out in a paragraph. Students don't like that as much. But this is, again, it's a summary on page 110 of the three types there are. You will encounter some of this in your Big Ideas assignment, but for right now, that's what we're going to do. Just look at that. So let me share my screen for the other information that I want to give you. And please take your own notes. Some slides I'll be going through quickly, and some I'll take a little more time on if I want you to write them. So this is just on flowchart and paragraph proofs. That's why we're not doing formal notes on them, because I'm not testing you on them or anything, but this is in lieu of a official paragraph and stuff like that. So this is just a warm-up. Complete each sentence. If the measures of two angles are blank, then the angles are congruent. Do I have a volunteer to tell me if the measures of two angles are blank, then the angles are congruent? Anybody know? Speak
90
up.
degrees.
90 degrees is not the correct answer. It's true.
Isn't it for
only
one?
one. Equal. Did somebody say equal? If the measures are equal, then the shapes are congruent. Very good. Now, number 2, if two angles form a what, then they are supplementary.
Linear pair.
Very good, Annika. Very good. Linear pair, then they're supplementary. And if two angles are complementary to the same angle, then the two angles are what?
Right angles.
They're not right angles. This is one of the theorems that we talked about yesterday. So look on your notes. Ones that we just did. Congruent, very good. Thank you very much. Ding, ding, ding. So equal, linear pair, and congruent. Very good. Those were from yesterday. So don't worry if you didn't get it, but that was a warm-up. So our objectives for this next few minutes are to write paragraph and flowchart proofs using deductive reasoning. So these are the only two vocabulary words. I just showed you what they were in summary. So now we'll talk about a few in detail. So again, like I said, it uses boxes and arrows to show the structure of the proof. Okay, the justification or the reason is written below the box. And here's an example. Now we have another theorem that we're adding to our toolbox. Okay, and this theorem is 2.7.1, common segments. We did it as a proof, actually. But if you have 4 points that are collinear, A, B, C, D, as shown, so it's in that order, if you know AB is congruent to CD, then from A to C is also congruent from B to D, because they have B, C in common. So hypothesis, conclusion. You now have a theorem that you can add to your toolbox. I see you should be writing it down. Thank you. Sorry, I went off the screen. Here we go, back on the screen. Okay, so that's called the common segments theorem, and we can now use it. And that's really all we have to do is like introduce it and we can use it. So it's in your book, and I will post this later if I go a little too fast, but otherwise I'm going to go on the next slide. And here's how you would read a flowchart proof. So say you have an angle like this. We did this proof the other day as a 2-column proof. 2 and 3 are complementary. 1 is congruent to 3. You want to show that 1 and 2 are complementary. We did it backwards. We started with these and we showed that these two were. But anyway, you start with a given here and then see how they've got a given on this whole separate column. So they did them separately, but you end up with the same conclusion, right? We started with these being congruent with the given, and then the measurements are the equal because of the shapes. We started with this complementary, which means then we could say that the measures were equal, then substituted into here and ended up with the same thing. So hopefully you can see how a flowchart proof is exactly what we did. It just looks different. Okay. I don't find that they help me to think any more logically, but they're valid. Okay. So I'm going to go on to the next one. And here's the example that we did the other day. So it's exactly the same in a 2-column proof. It's just a little bit of a different order. Now, here's another example with segments. So if I give you this flowchart proof, you should be able to take this and turn it into a 2-column proof. So let's talk our way through it. They've already given us the plan. RS is equal to UV. So these single lines, those tick marks means that RS is equal to UV. And they're also telling us that ST equals TU. So that's why they have double tick marks. And we want to prove that from R to T is T to V. So I'm looking at it going, well, okay, if I add those together, it'll give me RT. And if I add these together, it'll give me TV. That's the segment addition postulate. And oh, look, it's right here. So they did given, and then they did segment addition postulate separately. But then from here, you can write straight down our S plus ST equals TU plus UV, because that's the additive property of equality. And then both of these, you can end up substituting. Follow the colors, okay? So you'll notice from here, this is red and this is red. This is blue and this is blue. So when you go down this arrow to substitute, you substitute the green for this red and the purple for this blue. And then from here, once you have equal measurements of segments, then you can say that they are congruent shapes. Okay, so any questions? So now we're going to go ahead and do on the next page. Let's see what it looks like as a 2-column proof. Reasons given. Next, addition property. Third step, segment addition postulate, where we stated what these were. And see, like at this point, I'd be highlighting, like I would highlight that the same color, and I'd highlight that the same color, just to keep myself straight. And then I can substitute RT equals TV, and then that gives us there. So when I look at these, examples, I think, well, okay, I prefer this, but I've been doing this longer. And so hopefully at the end of this lesson, you'll be able to do both and go both ways and pick one which is the one you like. Okay, so now if we start with a 2-column proof, I should check for hands up if anybody has any questions. Then we're going to start with a 2-column and then we'll write a flowchart from it. So we have A, B, and C, and B is a midpoint. And we want to prove that 2 times AB equals AC. Again, we've done this actually in our notes already. So if B is a midpoint, that's given, but that gives us those 2 congruent segments, which gives us equal measurements. Well, then I can add, or I can use the segment addition postulate to say AB plus BC equals AC. Then I can substitute from here to here with AB, which gives us 2AB equals AC. If it was our first time seeing it, I would have taken a little longer. But here's how the flowchart works. Start with what you were given, you write given. What it was next. Next was, we said that the sides were congruent. From there, we can say the measurements are equal. And now, from there, we're going to say the segment addition postulate over here. And they're both coming to where you can substitute AB in for BC here. And then the last step gives you 2AB equals AC. Simplify. Any questions? Okay. And really where the questions will come is when it's your turn to do it individually on your practice. Here's another example. I have angle 2 congruent to angle 4. I want to prove that the measure of angle 1 is congruent to the measure of angle 3. That should say equals, actually. So here's the proof. These 2 are congruent, given. 1 and 2 are supplementary. 3 and 4 are supplementary. That's the linear pair theorem that we now have. That means I can then just say that angle 1 is congruent to angle 3, because that's what the congruent supplements theorem says. We got that yesterday. And now I can say that the measurements are equal. So that's a little bit of a typo. And that's just the definition of congruent angles. 4 steps, bam, wrote it right out. Now, if you want to do it as a flowchart, start with your given, See, and this is almost going to be sideways. Then you can state the supplementary. Then we can use the theorem we got yesterday to say this, and we can state that they are equal. So it can be shorter, it can be sideways, it can just be totally different. Another thing theorems do for us, like these two theorems, in our first few proofs from last week, we had to write out every single step. But now that we have theorems, once we prove that, we can just use the theorem. And so it will shorten our proofs quite a bit. You just have to know your theorems or keep your notes in front of you at all times. All right. This one won't take as long, but a paragraph proof is just what it sounds like. A style of proof that presents the steps of the proof and their matching reasons as sentences in a paragraph. This style is less formal, but you still need to include every step. So if you are the type of person who likes to write out your sentences, you might like this. Here is what I want you to write down in your notes. For sure, these two theorems are really nice to have. And now we're going to have the vertical angles theorem, which simply means vertical angles are congruent. So if you have A and B that are vertical, then you get that they are congruent. Period. Nice and easy. This 2.7.3 is really handy. If two congruent angles are supplementary, then each angle is a right angle. That's the only way it will happen. So you can see, you can abbreviate it, congruent angles, supplementary, implies right angles. It's the only way two angles that are the same can equal 180. They have to be 90 degrees each, which forces them to be right angles. I'm glad to see everybody's writing this down. Thank you. It makes me happy to see you writing these down in your notes. Of course, it's also adding the information into your brain. I'm recording. Okay. So I'll give it a few more seconds. Check to see if there's any questions. No. Okay. I'm going to go ahead and move forward to the next slide, just so you can see what a paragraph proof would look like. This is a classic example. This one right here, this will show up a lot more. So make sure that when you look at this slideshow later, you'll see it. All right, so if I tell you that 1 plus 2 is equal to 4, that's what you're given. 1 plus 2 is equal to 4. You want to prove that 1 plus 2 plus 3 is equal to 180. So it's given that 1 plus 2 plus 4 is 1 plus 2 equals 4. 3 and 4 are supplements, right? These two are supplements by the linear pair theorem. So that means 3 plus 4 is 180. And if that's the case, then you just substitute the 3 for the 4, and you get measure of 3 plus measure of 1 plus measure of 2 equals 180. Boom, done. Of course, you could do that in 4 steps in a 2-column proof, but that's how you do it. You just write it out. Okay. Here's what it would look like. You start with given. You say these are supplementary. You add those together to equals 180 from that definition. And then you substitute. So again, we're going to be practicing these more today, and tomorrow we will be doing more of these under the camera together. So today's your practice day, and I'm not going to go through this one. It's too much. They'll get. You can see those later. Again, more examples. Here's your 2. You can use vertical angles theorem now. You can use your complement theorems now. So 1 and 2 are complementary. You want to show that 3 and 4 are complementary. Given. Well, 1 plus 2 is equal to 90. That's the definition of complementary. We also know that 1 is congruent to 3 and 2 is congruent to 4 by the vertical angles theorem, which you now have. Then this next step is we're going to say that the measures are equal, which is the definition of congruent angles. Then we're going to substitute the 3 for the 1 and the 4 for the 2. And once the measurements are equal to 90, then they're complementary definition. So this is what it looks like. It's the same things, just all written out. We'll spend more time on it in chapter 6. That's why I'm going a little fast. And I think that I don't need a 4th example. Okay, so here's the thing. If I were going to give you a little quiz, a couple of questions here. Do you think you could write a flow chart from here? Or do you think you could write a paragraph from here? And again, I don't want to take up too much of your time because I want to give you time to practice during the period. But this would be like a perfect little proof if I said, okay, try to figure this out as a flow chart, and here's what it would look like. Okay. If I say 1 and 4 are congruent, then I could say that because of the vertical angles theorem, 1 is congruent to 2 and 3 is congruent to 4. Then you could use the transitive property to say that 2 is congruent to 3. But this is, see, to me, this is messy. And I wouldn't like it that way. But I know some people do. I just don't do, multiple arrows and stuff like that. I like the 2-column proof better. Which, as you can see, here's a 2-column proof. That's the flow chart. And then a paragraph proof would be writing all these out in sentences. So it'd be 4 sentences. It is given that 1 is congruent to 4. By the vertical angles theorem, we can say this. By the transitive property of congruence, then we can substitute. Boom. So now you have 3 different ways to do proofs. Again, we're going to focus heavily on this one. This one only a little bit, and then this one we'll get more in chapter 6. So now I'm going to look back at my students and stare at you here for a sec. So at this point, are there any specific questions? Did anybody need more time on seeing the theorems? They're in your book and they're also in your journal if you need to add them there. Okay, but this is the last section for chapter 2. So after this, we will be reviewing the whole chapter and taking a quiz over all of it. Because I was going to give you a quiz over just 2.4, 5, and 6, but I think I'd rather review more. Xavier, question? Or are you just telling me you're here? Okay. Alex, question?
So what we just learned, are these for preference, or are we going to be quizzed on these? Or is that undecided so far?
No. The question will specifically say, there's a couple of questions in the Big Ideas platform. And it'll show a bubble, or it'll say, like, where do you write the reason? Where do you write the reason in a flowchart proof? And your answer would be underneath.
Okay, thank you.
And it's so because they're in the homework, I wanted to make sure you saw them. But the only things I'll test you on will be the 2-column proof. So that's a great question. Plus, I was thinking this quiz. as part of the review. So you could all like practice it, and you could ask those kinds of questions together before you actually take a quiz. Irene?
I didn't mean to raise my hand.
Okay. All right. So here's what we're going to do. You've seen the agenda. I showed you the summary in the class notebook. It's been 35 minutes, so I'm going to end my recording. You're all going to go to Big Ideas and practice. The 2.6 assignment is due by the end of tomorrow. And we will be doing some more proof practice under the camera tomorrow. Okay, let me stop this first. And then, and a few of you, I need to check attendance.